Okay, perfect.
Yeah, I think it did.
Okay, awesome, Alex. Yeah, whenever you're ready.
Cool. Yeah. Hey, everyone. This is Commit Boost Community Call number 0, the first one. Very exciting to see. And yeah, I think if you're here, you kind of know what Commit Boost is about. In short, it's like a middleware software that, essentially is this platform for implementing different proposer commitments. Again, if you're here, you probably can think of many proposer commitments that you like. The sort of first one we have on Ethereum today is just PBS with MedBoost. And yeah, super exciting effort to see. And I think we'll just go ahead and get started. So the first thing we have here would be commit boost updates. So yeah, I know some of you have been doing those sort of some research and also development around commit boost itself. It'd be nice to hear what the latest is there.
Yeah, and maybe I'll start with just a few things community BD wise that not everyone may be aware of, just progress wise. Obviously, having the first call, so appreciate everyone coming and joining. Uh, Entity wise, these are kind of practical matters. Got, I think, 5 or 6 law firms to actually volunteer quite a bit of time to do some analysis around the best structure of this, given not only regulatory considerations, but also just optimal for the mission of Commit Boost, which is a nonprofit, non-monetization, and where we landed with the US based 501c something. It'd either be a 3 or 4. Some nuances there that the IRS has requirements around that we're working through. And so hopefully the next month or so we'll get that going and set up. Yeah, we got volunteers from some top law firms to also help us set it up and then draft quite a few of the documentation that's required. And so that was a huge blessing and appreciate those teams. Have more on that coming shortly. From like a validator engagement side, as you see, there's many folks on. That's been really solid. We'll get into some of these details, but appreciate everyone testing on that front. And it's been awesome to get the feedback. Nothing major so far based on what we've heard. Definitely some things we need to expand on, but that has been positive. And then on the module side, continue to meet teams that we either hadn't spoke with before or are just random that are building on Commit Boost. But so it's been good to see. Throughout the calls, we'll make sure to highlight these and go through them. We'll have a couple today present. Funding wise, this is grant backed. There's 2 phases that I've broken this up to: initial grants and then longer term grants. Longer term grants, those conversations will be later this year. But short term grants, super excited to say we've at least been approved for 2 grants from 2 different organizations, which is great. One of them is pending, and one of them we're still in work for. So in total, we'll have 4 probably for initial funding. The biggest cost we have for this is actually the audits that we have to get through. And so that's super exciting. We'll have more details from the community once we get doc signed and everything in place for that. But it's just great to see, and we appreciate all the teams that are helping with that. And then from a technical perspective, we'll go through this, but the major thing we shipped was Commit Boost in its core functionality plus the PBS module. And so we've been performing testing on Husky with a couple 100,000 validators. Some of them are running ourselves, but some from teams across the community, but we'll have more on that later. The major things we expect to ship over the next few weeks is right now we just support Docker. So we'll get to binaries so you can build it from scratch and then freeze the API specs for modules. That's one thing we're prioritizing to make sure that we don't ship things under the modules that are developing today. And then the other thing, which we'll discuss quite a bit today, is just signature types for other type of commitments outside of PBS. This is like the BLS ECDSA conversation. So we still just need to try to get some consensus. Commit Boost can support both these, but as you support more, there is increasing complexity, which has a trade-off. And so if we can get some consensus among validators and module creators, then we think we're in a better place as a community. So with that, no other updates from my side. I don't know if people in the community have updates. One of the things we wanted to somewhat, and we can get into this later, is just any feedback validators have that they haven't been able to give, or module creators, sort of open up the call with that. And if there's nothing, I don't know if people want to speak up publicly, but if they have good or bad feedback,
What?
that'd be awesome. And then we can go into the next item.
I have a quick question. It's probably too early, but is there any sense of like release schedule for Commit Boost or anything like that? And if so, is there like something to look forward to soon, or on like a 001 or something like that?
Yeah, we've got the Husky stood up, but production wise, we are targeting to wrap up audits by November-ish. We're right now getting some quotes on the scope, and we're dividing into two phases. The initial phase being core functionality plus PBS, and the secondary phase being these additional signatures. And that will probably carry into the second part into later in the year, December and January. But yeah, targeting to sort of kick off audits in the next few weeks, and then that will take about a month-ish. And then yeah, around late October, early November is where we'll target being ready for production.
Very cool.
Any other questions, feedback? Awesome. Thank you all.
Yeah, it sounded like we wanted to talk about validators and their experience with Husky.
If there's any teams that want to publicly talk about that, it'd be awesome. If not, yeah.
Hi everyone. Okay, I'm Paco from the Stakely team. So we have been running commit boost on Oleski for 2 weeks.
Cool. And I guess it's working. No feedback or complaints.
I think we may have lost him.
Awesome. Yeah.
Okay.
And I'll just summarize the feedback we've been getting in the background. Some of the things that people on the call have highlighted is most of it has to do with the ability to integrate with all the different setups that are out there. One of the major ones we're working on is with Dirk and Vouch. And actually, yeah, Thorsten raised that. And so we've been talking with Jim. I think he's on the call, but trying to work through a process on the go forward for that and what needs to change and shift, but hopefully we can get at least as much compatibility as possible. That's been one area. The other is just binaries versus Docker. We continue to receive feedback where validators just don't run Docker. So we are going to support binaries. And I think those have been the major things. We'll go through the PBS module, but I think the positive feedback has been really around the metrics dashboarding. People really like that. It's probably visual, so that helps. But that's been the major themes we've been getting directly from teams so far.
Cool. Yeah, visuals are always nice. You just look at a terminal and it's a bunch of logs, and sometimes that can be very intimidating. Cool. Well, there's nothing else there. Next up on the agenda would be, let's see, discussion on how to handle signatures. I think there's a question of like, do we want to sort of support BLS out of the box? Maybe ECDSA is like a different signature scheme. And I think this kind of then plays into different modules that people are building and what's easy for them. Yeah, anyone want to jump into that?
Yeah, I think Kubi's going to lead a quick discussion.
Okay, cool.
Yeah, I think we have the issue also on GitHub. I'll just post the link here if anyone wants to catch up. So I guess essentially one of the key design decisions at the moment is around how do we actually issue, or how does the validator give out these signatures in order to make commitments. And so there are basically two main trade-offs that we are thinking about. The first one being, do we use the proposer key that is actually already being used with a different signing domain, versus do we use proxy keys? And if we do use proxy keys, do we use BLS versus ECDSA? And I'll just go like through some of the, I guess, trade-offs. So just starting with using the proposer keys directly. So to caveat that, the only way we would use it would be by using a different signing domain, such that there's actually no risk of any in-protocol slashing based on any signatures issued through commit boost. So very well aware of the additional sort of risk with newer experimental type of commitments. So the biggest advantage of that is that essentially there is no additional complexity when it comes to key management. So all of the existing infrastructure, especially also for node operators that are a little bit more institutional and have lots of processes in place around security policies and compliance and stuff like that, there's a lot of infrastructure that's already in place and can just be used out of the box. There's a slight potential additional support required for this a new signing domain, but potentially we can also use the application signing domain. But other than that, like we can just tap into the existing infra, which is really nice. And also on the commit boost software side, there's actually not that much heavy lifting required. So no local key source and a bunch of other things that we would have to put into place for proxy keys. So that's the major advantage. And with that, obviously, also comes that the adoption from node operators is also going to be way less friction. Then the downside of it mainly is that there's not this clearer separation of keys that are being used to like make these new commitments. That's one downside, and also that we are purely limited to BLS, because obviously that's what the current proposer pub keys are, which means that at least until the next hard fork, I don't know which hard fork will actually include the EIP, which will support BLS signature verification on chain, it is going to be much more expensive. So I guess that's one of the bigger downsides, and especially most of the module creators have been wanting to use ECDSA, which is obviously not possible if we use the proposer private keys directly. Then the other option is to use proxy keys. So not use the proposer key directly, but use a different set of keys, which then opens up the possibility to support both BLS and ECDSA. But again, with that come different types of trade-offs. So just for proxy keys only, the positive thing is, like I mentioned before, you have really nice decoupling from the operational security of the proposer pub keys, and it gives some node operators a lot more confidence in like making new commitments. And the main other upside here really is that it opens the door to ECDSA, which is much cheaper to verify on chain today. And the main downside is basically the complexity really on the commit boost side and the key management software. But then on top of that, once now we do open the door to BLS versus ECDSA, that in itself also has a set of trade-offs. Where BLS, as I mentioned before, we can tap into all the existing infra. BLS has this property of being able to shard the keys, and so that was a very important security requirement for some of the more institutional node operators, which is obviously impossible with ECDSA today. And obviously, with the nice thing with having proxy keys and then supporting BLS is that for node operators that actually do want to use their validator or their proposer public key, they could just reuse it as well. So you kind of can cover both use cases of reusing an existing key, but also actually using a new set of keys via this proxy key approach, which is pretty nice. And the main downside here, if we stick to BLS, is that again, it's more expensive to verify on chain. And then I guess lastly, just for ECDSA, the main downside really is no native aggregation. It can't be sharded, and it's not compatible with all existing key management infrastructure that's out there, which is obviously the case for BLS. And then the main upside really is the cheaper verification on chain, which is what the module creators are going for. So those are sort of the sets of trade-offs. And they're somewhat intertwined as well. So we have already spoken to a bunch of you guys on the call, but would be really good to get some input and some different voices heard as well while everyone is on here.
Well, I'm always happy to talk. So I think that certainly, from a testant's point of view and generally from the validating side of things, a validator's key, the key that we use to propose in a test and everything else, is always online and always available. So in that respect, it's as insecure as it's going to be. So having a proxy key, I don't think buys us a lot above what we already have. I mean, if we had a proxy key, the reality is it would be protected in pretty much exactly the same way as the existing validated key is. So we're not convinced we're actually going to get a lot of additional benefit from doing that. In addition to that, obviously you're putting additional keys in, we have to manage them, et cetera, et cetera. So it's not something I see as providing any additional security, any real additional benefits from above and beyond just using the validating key that we have already. And the other part of it, I'd say again, is not a massive fan of trying to use ECDSA for all of the reasons that you came up with. The only big downside seems to be that BLS signature verification is currently expensive, probably prohibitively expensive. That's going to get fixed in the next hard fork, where we have 2537, I think it is, coming in as the EIP, and that's going to allow us to verify signatures on chain relatively cheaply. So, yeah, I mean, and you ran through a whole bunch of the other things. Certainly from our point of view, having an additional key, certainly being, an ECDSA key, would be a significant startup pain, a significant ongoing pain to manage the manage the keys. It would be very much orthogonal to a lot of what we have already. And the other bit I never really understood was how we actually link the ECDSA key to the validator, because it seems like you need to verify a BLS signature anyway to take that step. So we're almost in the worst of all worlds by trying to move to ECDSA there. Obviously, the big downside of using BLS is that we're waiting for the next hard fork before we can do anything useful on there. Now, equally, we're not necessarily waiting for the hard fork on mainnet. We're only waiting for it on dev before it hits, well, Poleshki realistically. And at that point, there's the ability to start running tests and using it on there. So, it's not immediate. I don't think it's a long way away. Back end of this year, beginning of next would be the reality. Yeah, I mean, that's probably our view, and partly from an attestant and institutional point of view, partly from writing and using Dirk and Vouch.
One possible way to reduce the startup cost is to allow for the proxy key to be exactly the same as the key that's used by the validators, and so the startup cost would be maybe zero. Especially if by default there is no proxy key, like you kind of have to explicitly opt in with some sort of flag saying, I am using a proxy key, and then you go through the process of creating a different one.
I mean, I'm neutral on that proposal. I don't really guess I understand what a proxy key would bring in this situation, that wouldn't already be provided by using the existing validated key. Actually, one other thing before I forgot was you mentioned you mentioned the idea of using the application domain. The application domain in BLS, as far as the spec's concerned, or our spec is concerned, it's actually a mask. So we have a full range of bits that can be used. So you can generate as many different domains as you need, for each individual module or each individual message type, or whichever way you kind of want to slice and dice that. And again, as long as the code bases for signers are built that they understand this is an application mask, then they'll understand we're looking at non-slashable or similar. And equally, if we do have ultimately slashable items come into that, then we can code them in separately. But it gives us a fair bit of flexibility there in terms of selecting domain and or domains.
Yeah, and I think Jim had a good point around how you'd actually set up the proxy key. Like you're almost certainly going to need the validator to sign off with their BLS signing key over, say, the proxy key, public key, or something like this. So you're already going to need the ability to make BLS signatures, have like a custom application domain with the mask like he was talking about. So we'll need that anyway. And then it seems like then just a question if a module wants to support ECDSA or, you could imagine any signature scheme really.
So a question on that, like, don't we have the ability to use the 0x01 withdrawal credentials? That's either an ECDSA or linked to an ECDSA key or a smart contract. And that could be another way to sign off on a new type of key or use directly as the proxy key.
So many entities have no ability to use that. If you take Lido as a simple example, then it's a smart contract. So, there's no one that can generate simple signatures. Equally, any system that's non-custodial, the people running the validator, the operator, has no access to the funds of withdrawal credentials. So, there are situations in which that is true, but there are many situations also where it's not.
Yeah, and I also think from a security standpoint, it's better to separate these concerns as much as we can. So it's a nice idea, but probably better to give someone the flexibility of like, okay, this is how I'm thinking about my validator, rewards withdrawals, and then separately I have maybe some other ECDSA key for signing, a pre-conf module or an inclusion list module or something like this.
One like small consideration in addition to the cost of verifying BLS signatures is the cost of producing the signatures. It's on the order of, let's say, 1 millisecond. And for pre-confirmation specifically, let's say we want one pre-confirmation per transaction. That limits us to like roughly 1,000 TPS. So, yeah,
But that
just
would be
a minor side note.
That would be a situation if the actual validator signs off each pre-confirmation. So basically the flow goes through the proposer or the validator box rather than a delegated server.
No, I'm assuming it all goes through a gateway, but I guess that can easily be parallelized. So maybe my argument doesn't really hold. Because you could just have many cores doing the signing. So if you're doing like 10,000 TPS, then you basically have 10 cores that are dedicated to signing.
Do any of the module creators have any strong views on ECDSA other than the on-chain verification costs, or any comments?
So I think from what I understand, like the key is used for maybe two things. So first, authentication of the validator, but secondly also providing a key that can slash or that has access to some collateral in the case of a fault. And I think in that case, it's actually, or at least with current infrastructure, it's maybe easier to use ECDSA for that. We're also still developing our thoughts on this, and we'll have more soon. But first glance, I would say for this specific scenario, maybe ECDSA is also good to have at least, or good to at least support.
And what are like the main reasons? Is it just the on-chain costs, or is there anything else that we're missing?
So I don't think cost is a big factor, but maybe with for example, with providing collateral through protocols like Eigenlayer or something, this all supports ECDSA only for now. Maybe that changes in the future, but at least for now, that's the case. So I think we should support both.
Yeah, so in general, it would be way easier to represent the validator on chain through an ECDCA rather than a BOS key outside of the consensus layer, obviously. So I guess that would be the main value for module developers to use the ECDCA key to have a good identity of that key on chain.
So I'll prefix this with not having any knowledge about the module design or similar, but it sounds like you kind of got two things. One is linking a validator to an ECDSA or Ethereum address, right? So that seems like that's something that could be just a signature from the validator side. I guess the second one is accessing funds, which I'm unsure of. I'd imagine there'd be a smart contract wrapped around that to be able to carry out slashing operations. But I would assume that as long as you've got that message that's signed by a BLS key that says, validator X maps to Ethereum address Y, and you're comfortable with whatever verification you do there, that I don't just set it to Vitalik's address because hey, he's got enough ether anyway. There's, as long as there's something in there that allows you to confirm that the other way as well, then that should be okay. And yeah, I mean, like I said, I think ultimately it sounds like there are two realms, right? There are the realms of what the validator is doing, and then there's the realms of what the, if you will, account is doing. And the account A has funds that could be slashed, but B runs validators. So I guess that this account is kind of the thing that then links the two sides together, and that would be where I would assume you'd have, like we say, the messages or the linkage from execution address to validator.
So just to share, like at Nethermind, we have load operators, and I've been talking to some of them, and the main feedback has been, well, basically what QB said, and like the biggest drawback of using ECDSA is the fact that you cannot like split the keys and have a distributed management system, because a lot of them have, what they do is they have a threshold like 3 out of 5 kind of thing, and to increase their security. And yeah, one idea was floating around internally was that to use a multisig for this, you can actually split the ECDSA, and multisig verification should be much more smaller than BLS key. And I think BLS signature checks are pretty expensive. So that seemed like a good intermediary solution.
Okay, I'm kind of hearing we want both, which maybe is not the answer we wanted.
Well, again, I'd be aware of the difference of where you want both, right? It sounds like people are okay with using BLS to identify a validator and then needing ECDSA potentially for inside the smart contract system that handles things like slashing and similar. So it sounds like we've actually got a relatively clean separation between identifying the validator, which we use a BLST key to do, generating pre-cons and similar, which is fine, but then separately the operational piece that runs through smart contracts will run on ECDSA, which again seems reasonable if you're using Ethereum execution addresses to hold funds, and they'll be the things that again will potentially run the smart contracts and carry out slashing operations and similar. So although we kind of end up with both, I don't think it sounds like it's a terrible thing. I think it's actually keeping each sort of curve in the place where it kind of belongs.
Yeah, that makes sense. Anything else on that, Kubi?
I think that's everything, but some good comments. So happy.
Cool. And yeah, maybe just to surface it from the chat, there will be precompiles for BLS signature verification coming in the next hard fork. So it's expensive today. It will not be expensive soon. At least it will be reasonable soon. So something to keep in mind. Okay, thanks everyone. I think next we had some presentations, maybe, or at least some discussion lined up for various modules people have been working on. I don't know who wants to take over there.
Maybe start with the PBS module.
Yeah.
And then inclusion list and then pre-comps.
Hey guys. I'm just gonna share my screen, but I don't see the. Do you see it? Oh, it looks like we cannot share the screen.
And Drew, do you have to give us permissions?
Right. Well, in the meanwhile, so the PBS module essentially.
Right now. Sorry, guys. Call 0. Expect technical difficulties. Did it work?
No.
No.
Okay.
So
You want to ping me the link? I'm sorry. Ping me on Telegram and I can share it.
yeah.
And then
An easy way is to make someone co-host. Kind of right-click on their name.
I just tried that.
Okay.
They're the host actually now.
Yeah, I cannot share.
No.
Yeah, let me just send you the link. Yeah, so in the meanwhile, the PBS module is essentially feature complete in the sense that we've been running it for some time on Oleski. So far, looks good. It's pretty much equivalent to the current ME Boost Go client in terms of the functionalities. There are a few things that are different. So one is everything around observability, telemetry, metrics. So we collect metrics that then we show on the dashboard that Drew is gonna hopefully share soon. So this dashboard is something that probably institutional stakers have already to some extent, or probably even more sophisticated, but I guess all the smaller solo stakers don't really have. And it's quite, yeah, if you go to the PBS metrics, yeah. So here, for instance, for every call that we have in the Builder API, we measure how much relays take to answer. and if they give an error, if they're registered okay. So if you scroll down actually to the get header, which is the most interesting one. So especially when you measure latency, different relays will have different latencies, and this dashboard give node operators a clear insight into what's happening in their box. So for instance, on in the bottom 3 panels are the ones with all the latency metrics, and it's easy to see how different relays will have different latencies, either because they're far away or maybe they're just delaying the reply. On top of that, we have a few other enhancements, which is essentially around how validators can customize when and how to request headers to relays. So one point is that we really want to make sure that there's enough time to go through the PBS pipeline. And the reason is that the default behavior is to wait for all relays to reply with some timeout. But originally, the timeout didn't really depend on where in the slot the request came from the beacon node, which means that if the request came later in the slot, the timeout would still be fixed regardless of what the time in the slot was, which can be problematic. So for instance, last month we missed a slot on Oleski because for some reason, I think there was a problem with the box, that it was running too many validators. But the request usually comes around 150 milliseconds in the slot. But I think that slot came something like 2 seconds, which is quite late already. But because we had no logic around that yet, we still waited for relays to reply. And by the time we requested the payload, it was too late, so we missed the slot. So now we have some safeguards, which essentially does that if the request comes very late, then we might decide to skip entirely the relay requests and directly return no headers to force the local build. So we'll be missing some MEV, I guess, reward, but at least there's no mislot, which is the largest part. All of this is customizable by the node operator. So there are some reasonable defaults, but if the node operator feels a bit more conservative or more aggressive, they can customize this. And on top of that, we also have some customization around how, for each relay, how frequently and how many headers should be requested. And that also allows node operators to customize. So for instance, for relay X, I know they're quite fast and they're maybe very close to me. Maybe I'm gonna request a header 5 times because they reply in 10 milliseconds. And because headers tend to increase in value over time, that means that if within, again, this timeout and within the safety guards that I was mentioning before, there is time to request multiple headers. Yeah, those are the main, I think, differences with regards to the, let's say, the MEV Boost client. Yeah, all of these.
When you do multiple.
Sorry, go ahead.
Sorry, I was just curious. When you do multiple requests, do you take the maximum bid across all the requests, or do you take just the last bid?
Yeah, we currently take the last one.
Okay, great.
Yeah, so all of these parameters are, let's say, again, by default is just equivalent to a MEV Boost. So there's just one get header, and then it's up to the relay to decide how much time to take. But then this can be customized by the node operator for each relay, and all the timeouts and all the safety guards are fully customizable as well. yeah, so the node operator has full control of the sidecar. Yeah, that's pretty much the PBS module. Yeah, I wanted to show some logs as well, but kind of share the screen. But essentially, we have some also apart from the dashboard, we store logs also to files. There's rotation. There's log pruning. So all of these, let's say, not super exciting stuff, but I guess around observability and metrics, which are useful. Yeah.
Because your PBS module is written in Rust, do you know if it's significantly more performant than the Go version in terms of making the request and processing the response?
I don't have any, let's say, data on that. I would expect it to be more performant, but at the same time, I think performance is not the main focus. I think the main focus is around, reliability, and let's say making sure everything works nicely. Yeah, maybe on the single call, yeah, it's slightly more performant, but the processing itself that the sidecar does is very light because it's essentially just multiplexing some calls to different relays most of the time, to the point where, yeah, the timeout that we have from the beacon node perspective is the same that we use for the relay, which basically means that we assume the internal overhead is basically zero because there's very little things to do in the sidecar apart from verifying a signature maybe, or checking that the bid is greater than some threshold, but it's very, very light stuff. Yeah.
Sorry, one question. Sorry, I haven't noticed. Does this dashboard include? Probably it will be useful to reflect the latest slot for each relay, because sometimes relay is stuck on some slot, and it looks, but it responds with 200, but in real life it like stuck on the some slot, or it produces some incorrect information. Probably it would be useful to. It's just a proposal for you. How to, and yeah, and the second, probably this relates. I don't know. I don't remember. Does it exist on the current config of commit boost? But probably it would be useful to add some fallback addresses for each relay. That's one it's not working, and you for each relay, it will be fallback to another one. Second point.
Yeah, good points. So on the second one, there's no fallback URL, but is there an advantage rather than using just adding another relay, even if it's the same, you're just getting more headers? I think that would also work.
Yeah, probably. Thank you.
Yeah. Any more question on comments, feedbacks?
I think there's one question in the chat. I don't know if you guys can see it from M-Team or Matthew. I don't know if we can answer that on the call, but.
Yeah, we don't have any metrics around latency. We can get those. I wouldn't expect that to be massively different, or yeah, as in the latency for timing games is dominated by network latency.
Yeah, maybe just to provide some context here, I think the like the average latency should be very low and not matter. But if there's spikes in latency that it could occur, for like multiple modules playing poorly together, I can imagine that would be a problem.
Yeah, well, for the PBS module is just single module that is running on. Even if you're running multiple modules, the PBS module will go, has its own threads, and unless you're running something that is like choking up your box, but on a normal, let's say, normal box, normal machine, they shouldn't be interfering with each other.
Cool. Thanks for the overview. Did we want to go to the work on an inclusionless module next?
Yeah, sure. Hi everyone, I'm Eitan. I've been working on the inclusionless module. So I'm gonna link the repo in the chat. If you wanted to take a look. There's in the README, there's a nice write-up that Julian from the Ethereum research team wrote that kind of gives a high-level overview of what this module does, some of the design decisions. But at a high level, this is an out of protocol inclusionless module powered by commit boost. Pretty much when you run it, what it does is subscribes to your local mempool, loads your validator keys into the commit boost signer module, launches a commit boost PBS module, and then the inclusionless module itself checks if there are any upcoming proposal duties for the keys that were loaded into the signer module. And let's assume at slot N, we have some block proposer duty. Then at slot at N-1, we check if we check the block at slot N-1, and we check first off, is there any room in that block for additional transactions? If there is, we take a look at the local mempool and see if there's any transactions in the local mempool that paid a positive priority fee and could have been included in that block. If they could have, then we use those to build an inclusion list that we then forward to the relay. And then when we get the block from the relay, it should include the transactions from the inclusion list. This is all done optimistically. So we've chosen optimistic enforcement because we're not introducing any like additional trust assumptions on the relay. And also we wanted to like reduce the amount of friction. So, we could have some type of like proof system that verifies that the transactions in inclusion list were included in the payload. But that might, cause additional friction. And at the end of the day, that still doesn't like mean that the block itself was valid. So we're not like introducing any additional trust assumptions. Yeah, so you can read through the README, as I said, for like a little more detail. I don't want to kind of go off on too many tangents here, but I think right now I have this module running on a DevNet, on the Helder DevNet, with like 300 validators. And some of the next steps for this module is to add, a little bit more metrics, so that you'd have a nice Grafana dashboard like we do for the PBS module. Get some more eyes on the repo itself. So, Julian from the ETH research and maybe some other people have looked at it, but it'd be nice to get some more eyes on it. Look into the code, maybe even an additional contributor or two would be cool. And then get this tested more thoroughly on Holsky across like a large set of validators. Have other groups running this and give their feedback. Those are like the the main things I'm looking for in the short term. But yeah, this is just a quick overview. If anyone has like feedback or questions, you can let me know here, or hit me up on GitHub. You can raise an issue. But yeah, that's about it. Oh, I guess one thing I also wanted to give some like feedback on commit boost real quick. I think one like cool little like wish list tool would be some like kurtosis tools for commit boost. That would, I think, make like the development process a little quicker. And yeah, one thing that maybe we haven't talked about what's cool about commit boost is I think it's also like an interesting tool for core devs to test like different commitment schemes without having to make like in protocol changes. So, like this inclusion list module, for example, like if this was out in the wild on mainnet, we could see how relays respond, how builders respond, and maybe get some like interesting, feedback without making like, these big in protocol changes. So I think it's also like a cool tool to use to like iterate on different ideas. That's about it for me.
Thanks for the feedback. And by the way, yesterday we discussed it with Lorenzo, the kurtosis support for local development. So yeah, that validates our assumption. We had the same issue as well.
Yeah, I also agree on that. So because there's a if panda ops Ethereum package kurtosis, if commit boost can add like a flag inside that repo, it would be nice.
Yeah, kurtosis is super nice for testing and things. So I think it'd be a really nice addition to support commit boost there. We are coming close to the time we have for the call. Do we want to quickly touch on pre-comps? Maybe just a quick overview on the module there.
Yeah, Puffer and Lubin, you guys can go through quickly. And we can push one of you if you want to the next call, but maybe start with Puffer real quick.
Sure, I can do it in 1 minute, so hopefully there's time for both. Cool. Okay. Everyone, can you see my screen? Cool. Okay. Yeah. So we're working on an AVS for handling registration and slashing for these AVSs. So the goal here is around 100,000 validators on EigenLayer right now, and we want to try and get them to participate in pre-comps to start, but proposer commitments more generally. And one of the goals here is to find that sustainable source of yield for these LRT holders, and also to funnel more people into using commit boost. So the problem statement here is we need an on-chain registry, and we need a way to slash the offending validators. And right now, there's an effort to build like this neutral on-chain registry, and we intend to use that as part of this. Like we don't want to build something competing with that fragments. So the scope of this AVS is to allow native restakers on EigenLayer to be able to register in. We need to handle rewards, and the way that rewards are handled today in EigenLayer like requires some kind of MEV smoothing. So we're going to have that off the bat. And we need to handle 3 slashing cases here. So liveness faults, safety faults, and rug pooling to tie back to this whole MEV smoothing part. So if a validator isn't sending rewards back to be smoothed, that would be another additional like commitment that they're making. So the requirements here is that they have to run an eigenpod. And this comes back to the conversation of like which keys to use. So in our case, we have it pretty easy because every validator is going to have one of these eigenpod contracts, and there's a dedicated pod owner that's either a another like wallet or a smart contract, and that allows you to kind of in our system set the delegate key that you wish, and that could be either your same validator key or an ECDSA key. It's really arbitrary. And I guess I'll kind of really want to talk about the roadmap here, but the idea is we're going to have 3 types of modules, one for rewards, one for registrations, and one for handling these disputes. But the roadmap here is we just launched on Helder. We're going to be kind of adding a lot of support to be able to interface with it and start working on rewards really soon. And as soon as that's ready, go to Holsky and get hopefully something to mainnet soon, so we can really start getting people to start using this. Unfortunately, slashing isn't live on EigenLayer yet, so that's really TBD on when we can go live there. But we're going to start really with adding the logic first. So yeah, thank you, everyone.
Cool, thanks. And then was there Lubon? We could briefly look at that.
Yes. Give me 1 second. Okay. So I think in interest of time, I'll just, I guess, walk through the system diagram a little bit. This is the current version that's running on Commit Boost DevNet Helder. So we mostly use Commit Boost to handle the signing from the validator. And also we extended the Builder API using the Builder API module from the Commit Boost with some extension API methods that all of which are here. So if a user wants to send a pre-confirmation, we are call data agnostic, meaning that when the pre-confirmation doesn't necessarily ask for the transaction content, but only the gas limit. Once we receive the pre-confirmation request, we just put that into a private mempool internally in our pre-confirm rule, and it's strictly ordered by priority fee. And when the block comes, the user can submit the transaction call data to the pre-confirmer through this extended Builder API. Then we return the commitment. So in the process, the pre-confirmation will be signed in real time by the validator through the Commit Boost. Then we'll post the constraint to the relay through the constraint API that's being implemented by the relays. And also, we currently have a modified Flashbox builder running. It's mostly for as a fallback solution where there's no builders that are respecting the constraint that's posted by the validator. We simply build a block that include those transactions, but they only serve that particular purpose. So next step, currently we're relying on a Ziggy code processor to do the inclusion proof. We recently figured out a way to do the Mercury inclusion proof for pre-conf of inclusion, and that's basically the future roadmap. Just one small suggestion to the Commit Boost. I think it would be nice to have some kind of a configuration file within the Commit Boost to allow the validators to to configure what kind of a transaction they will accept, or what kind of a transaction that they don't want to accept. A simple example will be, for example, OFAC transaction addresses. Depending on the validator's regulatory risk tolerance, they probably don't want to include transactions that's stemming from any addresses that were associated with OFAC sanction addresses. So I think it will be better for some external party to help the validator to handle this to reduce the regulatory risk. So that's it.
Sorry, quick question on that, on the suggestion. So you mean it for the module to have additional configuration file, or for the PBS module?
I think that's actually a good question. Depends on how it's being implemented. I think the way I see it is just having the signing module where the validator does the proxy signing. It actually checks where the transactions are stemming from. If it's an address that was, for example, OFAC sanction address, then it simply says, I won't sign this particular transaction as a pre-conf transaction. So something like that.
Yeah, I think from the sign and module point of view, what it signs are usually opaque, digests. So I think maybe that's something that should be done in the module, which has all the business logic of the I guess commitments modular scheme. Yeah, but
Gotcha.
all the configuration file that's already present is fully extensible, and that's already live, where you can add whichever configuration extension, so to speak. So yeah.
Gotcha. Thank you.
Cool. We are at time, so I think we should go ahead and wrap up. Drew, is there like a place people can keep coordinating? Again, thanks everyone for joining. And yeah, I think there's been a lot of good discussion just here and in the chat as well. Any place to coordinate asynchronously in between the next call?
We're working on it, but we're probably going to say like that. We have individual chats. So if people want to ping us, but we're working on something for the whole community. Just wanted to kick off the call first. The repo is always open to if people want to raise issues.
Okay. Awesome. Thanks, everyone. I think we'll go ahead and wrap then.
Thanks, y'all.
Thank you.